side, 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 and side, angle, side, triangle congruence notes. So what this section is about is being able to prove that two triangles are going to be congruent based on what you know. So the first one is side, 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 and we abbreviate it with SSS. And so the SSS just stands for side, side, side. And this is one of the easiest ones to identify. And it just says if three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. So for our first one, if side MN is congruent to QR, so this side, and side NP, and of course we know we've got it marked with these two sides, is congruent to RS, so this side, we got it marked with those sides, and PM is congruent to SQ, so this side right here, and it's got 3 marks. And so notice there's a different number of marks through each one. Like MN had 1 mark through it, and QR had 1 mark, and NP and RS each had 2 marks through it, and PM and SQ each had 3 marks to it. Then we can prove that triangle MNP is congruent to triangle QRS. So that's side, side, side. And like I said, this is one of the easiest ones to prove. It's the most obvious. So then we get to side, angle, side. And we abbreviate SAS. So this is side, angle, side. If two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. So if we have side PQ is congruent to WX, and then we have angle Q, so angle Q is congruent to angle X, and then we have side QS is congruent to side XY. Then triangle PQS is congruent to triangle WXY. So let's talk about the included side. So notice how it's the angle that's in between the two sides, or the two sides that form the angle. So it's always the two sides that actually form the angle that it's making. So if we go over here to the side real quick, and let's just draw some triangles. It's always the two sides that form the angle. So for example, if I highlight, let's say I just highlight the sides that are congruent, okay? It's going to be the angle. It's got to be the angle that is formed by the sides that I've highlighted. So for example, it would have to be this angle that we talk about. That's side, angle, side, because it's the angle that's highlighted, in other words. You wouldn't use this angle down here because notice this side is not highlighted at all, okay? So if I were to use, if we get rid of this here, and if I draw a couple of other different shaped triangles, so let's say, you know, we form these triangles, and let's say I highlight these sides. Those are my congruent sides. It's going to be the angle that's formed. It's going to be the angle in between those highlighted sides. So I'm going to do this angle and this angle. This is our side, our angle, and our side. Side, angle, side. And there it is, okay? It's not going to be this angle over here. It's not going to be that angle, because if we use that angle over there, that doesn't even form. And obviously you can see it almost forms a bad word, and we'll talk about that later on You can't even prove congruent triangles by having angle side side. Angle side side doesn't even work with congruent triangles. We'll get to that later. Okay, so that doesn't work, and that's one way we remember that is because we don't abbreviate it using angle side side. It doesn't work. We can't have congruent triangles with that method. Okay, all right. So back to finding our side, 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 and side angle sides. Oops. Okay, so determine if the two triangles are congruent and state how we know if it's side, 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 or side, angle, side. Okay, so first of all, in this first one, if we, we'll just kind of highlight what we know. So we know that this side is congruent to this side, and we also know that we have the congruent angle here. We got a 90-degree angle, so we have a side, and we have an angle. Now, what we haven't talked about is that these share a side. They share this common side right here. So they share that. So this triangle has side, angle, side. We've got side, angle, side. And then this triangle has side, angle, side. So these triangles are congruent through side, angle, side. Okay? So in our next triangle, we've got this side is congruent to this side. We have this side congruent to this side. And they share this side. So these two triangles will be congruent through side, side, side. Okay, so moving on. We have this triangle. These sides are congruent. We have these sides are congruent to each other. And then we have this angle is congruent to this angle. But we got to be super careful on this one because this pattern, if we look here, we have side, angle, side for our pattern. And then this one we have side, side, angle. So this pattern follows our side, angle, side pattern, but here it does not. Okay, in fact, we get our bad word here, angle, side, side, or side, side, angle, okay? So you have to have the pattern in both triangles for it to work. So this one is none, okay? This one does not work. All right, if we look at D, we have this side and this side is congruent to each other. We have this side and this side is congruent to each other. And they share that middle side. So obviously it's congruent, so this one is side, side, side. All right, if we look at our next one, we have this side and this side is congruent to each other. They share the middle side. And then let's look at our angle. We have this angle and this angle. So let's check our pattern. Let's look for the side, angle, side pattern. So here we've got the side, angle, side pattern. So the side, angle, side pattern in this triangle. Now, here we've got the angle over here. Angle, side, side. It does not follow the pattern that we need. It's got to be in both triangles, so this one is none. If we look on F, we have a side and a side. We have this side and this side. And we have our 90-degree angle. Check for your pattern. Obviously, the two sides enclose that angle. We've got side, angle, side, and side, angle, side. So this one does follow our side, angle, side pattern. Okay, this one we've got our side. They share the side in the middle. And then we have that angle marked here. So let's just look for our pattern. We have our side, angle, side there. And there's our side, angle, side that follows our pattern. So we are good for side, angle, side here. Okay. Now on these, you may notice right off the bat that the angle here is not in between this side, is not in between those two sides. In fact, our angle is supposed to be, it should be right there in between those two sides. So just looking at that triangle right there, you can tell that this one is going to be none. And same thing over here. This angle is not where it needs to be. It should be right here in between those two sides. Okay, so example 2 says state what additional information is required in order to know the triangles are congruent for the reason given. So it wants us to use side, angle, side, okay? So we have two sides are congruent in each triangle. We need the included angle. So we need the angle in between our two sides. So we need this angle and we need this angle. So we need to know that angle L is congruent to angle H. That's what we need to know. Okay, on B, we need side, side, side. It wants us to be able to use side, 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 side. Now, it already gives us this side and this side. And technically, it has already given us this. If it shares a side, that is something that is given. So we don't want to tell us that XZ, we don't need to know that because it's shared. We already know that. So we need to know what's in blue, okay? So we need to know that XD is congruent to ZY. That's what we need to know. All right, for C, side, angle, side. Well, we've already got one side and one angle that's given. So we need to know these sides. And it's important that you go in a proper order. So, for example, if we're going to start with U, if we're going to go from U to W, like we started with that right angle, we need to start with X first over here. So that order is important when you are naming these things. Okay? All right, and side, side, side. This is probably one of the easiest ones. We just need that third side. So obviously we need this side right here. So EG is congruent to YW on this one. Okay, so let's do a little bit of guided proofs. You'll never have to do a proof completely on your own. We'll have to do guided proofs. Now, proofs are something that, or you just go through steps. It's like a process of what do you need to know to show that triangles are congruent. You always start with the given information. That's just part of a proof. Proofs are something in geometry. You used to have to do it a long time ago, and you would have to used to do it like from scratch. Like you would have to list everything. But these days, you just kind of have to like fill in the blanks for proofs. It's like they'll give you part of it, and you just fill in the blanks. And a lot of proofs, what they are, it's just a lot of definitions. It's just definitions for math and explaining is all it is. It's just kind of filling in the blank. So the first part of a proof is just the given. So you're given that AB is congruent to DC and AC is congruent to DB. And you're trying to prove that the two triangles are congruent. So mark what you know. So AB is congruent to DC and AC is congruent to DB. Now, since these are different lines, make sure you do different marks. Now, prove that triangle ABC is congruent to DCB. Okay, so what congruence postulate could we use to prove the triangles are congruent? Well, it looks like that we could probably use side, side, side. Because notice we've got two sides, and it looks like that they share a side. And what sides must we show are congruent? So these are just guiding questions that we're just talking through. What sides must we show are congruent? Well, we need to show that BC is basically congruent to itself. And what property states that something is congruent to itself? And that property, that is called the reflexive property. That's called the reflexive property. All right, so now that we've answered these questions, we're going to write a two-column proof. So the way that you start it off is you always start with what's given. You just kind of repeat. So it's kind of like in English when you're answering a question. It's just like you restate the question. And that's what we're going to do here. Okay, and the justification for that is because that was given to us. All right. Now, our second thing was we said that BC was congruent to BC, and the reason for that was because of the reflexive property. Okay, and so now we have basically given a reason. We've talked about every side. We have talked about every side being congruent. So now we can say that triangle ABC is congruent to triangle DCB, and that's because of side, side, side. And that's our proof. We've just talked through why that those two triangles are congruent. So here's another one that we'll go through. Given that C is the midpoint of NB and C is the midpoint of MA, we are going to prove that NMC is congruent to BAC. So if we know that C is our midpoint of N to B, that means that these two parts are congruent. And if C is the midpoint of MA, we know that these two lines are congruent. So what congruence postulate could we use? So think about another thing that we also know about our angles. So think about something that we also know. So what kind of angles are formed here? We know that these angles are congruent, and remember, what kind of angles are those? So those angles, if you remember way back, those are vertical angles. And so now, so what we formed here is we formed side angle side. And so it says, what does the definition of midpoint tell us? It tells us that parts of the segment are congruent. And what sides are congruent by the definition of midpoint? Well, that just told us that NC was congruent to CB, and it also told us that MC was congruent to CA. And can we show that all sides are congruent? And if not, can we show that at least one angle is congruent? And so we were able to show that angle NCM was congruent to angle ACB because of vertical angles. We just talked about that. Vertical angles are congruent. And so now that we've answered those questions, we can do our two-column proof. So those were just our guiding questions that got us through our proof, okay? So remember, our first part was to list everything was given. C is midpoint, and I'm going to abbreviate a little bit here. C is midpoint of NB, and C is midpoint of MA. And so that was given. And I always number things together on each side. Okay. So then from there, we were able to say that NC was congruent to CB, because you always want to list all of your congruent parts. If you're going to use side, angle, side, you have to tell me what side is congruent, what angle is congruent, and what side is congruent, okay? Because if you're doing side, angle, side, you got to be able to tell me those pieces. And MC is congruent to CA. And that is our definition of midpoint. Okay, so now we've got those sides addressed. Okay, so now let's talk about that angle. We said angle NCM is congruent to angle ACB because vertical angles are congruent. And so basically now we've got our side, angle, side. So now we can do reason number 4. We can say our conclusion basically. Triangle NMC is congruent to triangle BAC. And that is because of side, angle, side. We said our sides were congruent, our angles were congruent, and our sides were congruent. And that's just basically talking through a proof. And so anytime that you would have to do a proof, it would basically be like fill in the blanks.